AI agents are autonomous software programs that perform specific tasks or make decisions based on data inputs. Unlike traditional software with rigid instructions, AI agents adapt and respond intelligently to changing situations. Traditional software follows strict rules and cannot handle unexpected changes. AI agents, however, use machine learning and advanced technologies to adapt dynamically. Think of AI agents as digital assistants capable of independent action, leveraging technologies like machine learning to achieve complex goals. AI agents leverage advanced technologies like large language models for natural language processing and machine learning algorithms for pattern recognition and prediction. Large language models, such as those used in systems like GPT-3 and DAL-E, handle natural language processing, allowing agents to understand and generate human-like text. Machine learning algorithms enable pattern recognition and prediction, helping agents analyze data and make informed decisions. Together, these technologies allow AI agents to interact effectively with users, systems, and other agents, enabling them to achieve complex goals autonomously. Autonomy is a fundamental characteristic of AI agents. It's the ability to operate independently and choose the best actions to achieve predetermined goals without constant human supervision. The agent decides what to do and how to do it. Rationality is another crucial characteristic. AI agents make logical, data-driven decisions based on their perceptions and available information to produce optimal results and performance. They strive for the best outcome based on the data they have. AI agents operate through a continuous four-step cycle. The first step is perception, gathering information from their environment through interfaces like sensors, customer queries, or system data. This is how they understand the world around them. During perception, agents collect different types of data, including sensor readings, visual information, textual content, and audio inputs. This comprehensive gathering allows agents to build a complete picture of their surroundings. In the analysis step of the AI agent operational cycle, the agent takes the data collected during perception and begins its thinking process. This involves evaluating the collected information, predicting what might happen next, and determining the optimal course of action to achieve its goals. The analysis breaks down into three key components. First, the agent evaluates the data, assessing its relevance and quality for the current situation. Next, it predicts outcomes by using algorithms to forecast potential results based on the evaluated data. Finally, the agent determines the best course of action, selecting from available options to maximize goal achievement. This diagram illustrates how AI agents process information and make decisions, showing the flow from data collection to action execution. The predictive model workflow shows how data sets are transformed into actionable insights through training and deployment, a key part of the analysis process. The third step in the AI agent operational cycle is action. After perceiving data and analyzing options, the agent executes the chosen tasks or commands to achieve its goals. During the action phase, the agent carries out specific operations based on its analysis. This could involve sending responses to users, controlling automated systems, or processing financial transactions. The action step transforms the agent's decisions into real-world outcomes. This data processing flow shows how information from databases leads through analysis to concrete actions, completing the agent's operational cycle. The final step in the AI agent operational cycle is learning. Here, the agent processes the outcomes of its actions, receives feedback, and uses this information to improve its performance over time. In this continuous cycle, the agent first perceives data, analyzes options, takes action, and then learns from the results. Learning is crucial because it allows the agent to adapt and become more effective with each iteration. During learning, the agent receives feedback from the outcomes of its actions. This feedback might include model performance metrics, drift detection alerts, or user satisfaction scores. The agent then recognizes patterns in this data, identifying what worked well and what didn't. This feedback loop, as shown in machine learning deployment diagrams, helps agents monitor model degradation and input drift. By analyzing these patterns, the agent can adapt its algorithms and strategies to maintain optimal performance. For example, monitoring production incidents, as seen in this performance graph, allows agents to detect when models need retraining or adjustment. Through continuous learning, AI agents evolve and handle increasingly complex tasks more effectively. AI agents use two types of tools: static and dynamic. Static tools perform predetermined actions with fixed functionality. Dynamic tools adapt their behavior based on context and changing conditions. Static tools perform predetermined actions with fixed functionality, like sending emails or retrieving specific data. Dynamic tools adapt their behavior based on context and changing conditions. Dynamic tools adapt their behavior based on context and changing conditions, as shown in workflow diagrams. AI agent architecture consists of three core components: perception and input handling, planning and learning, and adaptation. The first component, perception and input handling, manages the ingestion and interpretation of information from various sources like user queries, system logs, APIs, and sensor readings. This perception layer gathers data through interfaces and interprets it to prepare for decision-making. The architecture includes layers like the tool and retrieval layer shown here, which help handle inputs effectively. The planning component is crucial in AI agent architecture. It focuses on sequencing actions and determining dependencies between tasks to achieve goals efficiently. Planning breaks down complex goals into manageable steps, identifying what needs to happen first and how tasks rely on each other. This component also handles uncertainty by considering different scenarios and potential obstacles in the environment. Finally, planning creates optimal strategies by evaluating different approaches and selecting the most efficient path to success. These planning processes are illustrated in the agentic system architecture, where orchestration layers manage task sequencing and dependencies. A practical example is task allocation using dependency graphs, where agents determine the order of actions, like stacking blocks based on their dependencies. The third component of AI agent architecture is learning and adaptation. This enables the agent to recognize patterns, refine predictions, and adjust decision-making processes based on feedback. Agents use feedback loops to monitor performance, detect drift, and iterate on models. This process includes checking for model degradation and adjusting based on new data. The Plan, Do, Check, Act cycle provides a structured approach to continual improvement, helping agents plan changes, implement them, check results, and act on findings. Through pattern recognition and feedback loops, agents continuously improve their decision-making. This makes AI agents more effective and intelligent over time. The AI landscape has dramatically shifted in 2025. While previous years focused heavily on large language models, the spotlight has now moved to AI agents, with every major tech company and hundreds of startups actively experimenting with agent technologies. The numbers tell an incredible story of growth. The AI agent market is experiencing explosive expansion, projected to reach $47.1 billion by 2030, with a compound annual growth rate of over 30% from 2025. Companies are already reporting significant efficiency improvements across various sectors, with gains of 20 to 35% in overall operations. These improvements are particularly notable in customer service, sales, and human resources. Four major trends are shaping the future of AI agents. The first trend is autonomous systems, which are AI agents designed to operate independently in real-world scenarios, significantly reducing the need for human input. These systems can function without constant human oversight, making decisions and executing tasks on their own. They manage complete workflows from start to finish, handling complex operations autonomously. Examples include warehouse robots that sort and move inventory, autonomous vehicles for transportation, delivery drones for logistics, automated manufacturing lines, and robotic tractors in agriculture. The second trend is the rise of multi-agent systems, where multiple agents collaborate and coordinate to achieve complex tasks. These systems can handle problems that are too large or complex for a single agent to solve. A single agent is limited to handling simpler tasks on its own. In multi-agent systems, multiple agents work together, coordinating through methods like swarm intelligence to tackle complex challenges. For example, they can optimize supply chains by distributing tasks across specialized agents. This architecture shows how agents interact, communicate, and share knowledge within the system. A practical example includes an agent core coordinating specialized agents for tasks like weather analysis and online search. The third trend is the enhancement of independent decision-making capabilities in AI agents. This allows agents to weigh ethical considerations and long-term impacts when making decisions beyond just immediate goals. The fourth trend is the increasing use of edge computing, which brings AI processing directly to devices like IoT sensors and smartphones. This enables faster, more privacy-focused operations without relying on cloud infrastructure. AI agents are transforming industries across the board. In human resources, they screen resumes and identify top candidates by analyzing skills, experience, and cultural fit, significantly reducing hiring time. AI agents in customer service handle complex queries with unprecedented sophistication. They provide 24/7 support and resolve issues autonomously, leading to increased customer satisfaction. Marketing teams leverage AI agents to create hyper-personalized campaigns by analyzing extensive user data. These agents identify patterns in customer behavior, preferences, and interactions to deliver precisely targeted advertisements that resonate with individual users. For email marketing, agents automate campaign creation, scheduling, and list management while continuously optimizing content based on open rates, click-through rates, and conversion data. They handle decision points like follow-up emails for users who haven't engaged yet. On social media platforms, agents set and achieve goals like increasing brand awareness, managing reputation, driving website traffic, and generating leads. They analyze engagement metrics to refine posting strategies and timing for maximum impact. A master orchestrator agent coordinates all marketing activities, integrating data from various sources and managing sub-agents for audience segmentation, content creation, campaign management, and analytics reporting. These coordinated efforts result in significantly higher conversion rates, with retail chains reporting up to 25% boosts through agent-optimized email and social media strategies. The use of various marketing flowcharts helps visualize and refine these processes. Financial services deploy AI agents for fraud detection, real-time transaction analysis, and algorithmic trading. These applications reduce fraudulent activities and improve risk assessment accuracy. In fraud detection, AI agents continuously monitor transaction patterns to spot anomalies. Multi-agent systems coordinate tasks like forgery detection and risk assessment, producing detailed evaluation reports that help prevent fraudulent activities. For real-time transaction analysis, AI agents examine financial dashboards with metrics like accounts receivable, payable ratios, and key indicators such as DSO and DPO. This enables immediate risk evaluations and operational decisions. In algorithmic trading, AI agents manage complex systems with processing nodes, event queues, and automated traders. They connect to databases and external entities, executing trades based on predefined rules for maximum efficiency. For risk assessment, AI agents analyze presentation slides with budget comparisons, resource icons, risk pie charts, and quality bar graphs. This provides accurate evaluations of financial health and operational risks. Overall, AI agents in financial services deliver significant benefits, including a 50% reduction in fraudulent activities, more accurate risk assessments, and greater operational efficiency across fraud detection, transaction analysis, and trading. Future predictions for AI agent adoption are remarkable. Experts forecast that AI will handle 80% of all customer interactions by 2030. Even more striking, 85% of enterprises plan to use AI agents in 2025, representing a massive shift in how businesses operate and serve their customers.